Hi. Up next we have a cloud panel, and this is for people to talk about everything they know about cloud, and what these guys know about cloud is nearly everything worth knowing about the cloud. First, I want to talk a little bit about the sessions remaining in the day. In fact, Jinesh Varia, who is from Amazon, he'll be doing a session next at 3 o'clock, shockingly about doing things in the cloud, cloud formation. We also have a great panel by somebody from Media Temple about managing more with Puppet. And Media Temple's been using Puppet for a long time, and they're a hosting company out of LA, and they've always been very good at pushing the boundaries of Puppet. We also have somebody who's local from Jan Rain talking about Puppet, and then another cloud talk by David Lettercourt of Red Hat. I know we have sessions going all the way through the whole day until 6 o'clock, and I know you're all very interested to go and begin drinking as quickly as possible, but there are great talks all the way through the end of the day, so I recommend you stay. We've got Xenos and Puppet at 5 o'clock, and then doing development in the cloud at the same time at 5 o'clock. So the panelists now, we have Mark Hinkle from Citrix, and he's been traveling around. I have no idea how many miles he has, but I have never been to a conference without seeing him. And I go to a lot of conferences, so I know he travels a lot. We've got Jinesh, who's on the CloudFormation team at Amazon. Derrick.
I'm on the evangelism team.
On the evangelism team, okay. I've been talking to you about CloudFormation there. But, and Derrick Harris from GigaOM, who will be moderating the panel. And then Jay from Nimbula, and Rich Wolski from Eucalyptus. There, I remember most of it. There we go.
Afraid of my last name, aren't you? Afraid of my last name, aren't you?
Slightly.
Okay.
And I'll kick it off to these guys to, I'll kick off to Derrick to run the panel. Enjoy.
All right, great. So just for the sake of kind of clearing things up, we have 50 minutes, I think. We're going to try to leave about 10 minutes for Q&A at the end. So if you have questions, feel free to save them up and ask them at the end. So first of all, I mean, this is a really diverse crew of cloud experts, I think. So, I mean, I want to start off kind of addressing, looking at the various companies here, addressing, some of the business model aspects of cloud computing. Initially, you might look at an open source. We have 2 open source guys up here. We have 2 non-open source guys up here. I mean, can you talk a little bit about, I'll open this one up to the panel, but can you talk a little bit about the decision to go open source or to go proprietary and how that works?
Yeah. So I guess I'll start. So we do an open source project called CloudStack, and we started out as a company that wrote software that was not open, that we developed not in conjunction with users early on. And we just looked at the fact that in the server market, Linux became pervasive because we could, people like Red Hat, or companies like Red Hat and Canonical could focus on adding value at a higher level, and they could use these building blocks so that you wouldn't waste your time developing plumbing. You develop solutions to problems. And just like Linux became pervasive in the server, it was our opinion that open source cloud operating systems are going to be pervasive in the cloud, and we wanted to make sure that we could get good adoption and people could customize it to solve their problems. So it was inevitable for us to do that.
Right.
So I'll speak as the other open source company here. It's in our DNA. We came out of the university environment, and before we commercialized, we spent a lot of time building high-end data centers for the various government agencies. And it was clear to us for 5, 6, 7 years that data centers were going to be built out of open source software. We were using it in what we were deploying. It was very much part of the research that we were doing. When we were going to commercialize, it just didn't seem like there was any, it was even something we thought about. It had to be open source given all of the experience that we'd had with it and the uptake that we had seen with our own experience.
So I think there's 2 key questions. The first one is how do you get the best possible innovation? Because if you look at open source is hands down the best way to do something where it's a known problem and you're commoditizing something and you're doing incrementally in small enhancements. There's no question open source kind of beats closed source there. With real next bleeding edge innovation, I've seen it work both ways. I've seen great open source projects just be hugely successful, and I've seen other projects where closed source with a small team with very strict, this is what we're going to do, this is what we're not going to do, can get to innovation and hardening of that innovation and get enterprise ready in a quicker way. I think the jury's still out which way it's going to work with the cloud operating system. I'm not going to predict an answer. It could go either way, but we think there's a strong reason to think that it could be this small dedicated team with strict controls of what's in and what's out. The other aspect besides innovation is ecosystem, and open source is phenomenal for building ecosystem. If you're a closed source company and you want to build ecosystem, you have to try extra hard. And so you want to make sure that you want to modify your products in such a way that the ecosystem isn't just kind of bolted on, but really slides in and fits in and is a better experience for the end user. And that's the route we've taken. But like I said, time will tell which way. I think there's room for both of them. We'll see which one kind of ekes out an edge.
Yeah, just to kind of add to that, I'm sort of the odd man out here. As I see it, and as I believe, cloud in general is not just about the software, right? It's about the operations, it's about the hardware, it's about how you are actually connecting the hardware pieces with the software, and all the things that comes around what we call operational excellence, right? Those are things that are really not adding value to the business, right? In general way, you can add more value by adding, have open operating system and above. That's the open source ecosystem that we are building, and I'm really very proud about the fact that today, whether it's commercial software running Microsoft software or Oracle or even open source, any of the open source, that's also available along with all the open source tools that are available in the cloud.
Okay, but here's the reason open source is going to dominate the data center, right? The reason Linux wiped out Unix in about 5 years is because of its transparency. The time to remediation for a problem with Linux is light years faster than the time to remediation with any Unix system. And that's because when you have a problem, 100,000 other people have had that problem. And when you have the problem, you've all done this, right? You sit down, you type into Google the error message you get, and boom, you get the 10 best answers on how to fix that problem. That's not true for proprietary software. It's just not. Right? The transparency that open source gives you in a scalable environment like a data center is the reason that data center software will be open source.
I think Jay brought up an interesting point before, which is at this point we're talking about something as relatively new as cloud computing, right?
Sure.
As managing, a data center as a cloud. Like in terms of community contributions, where are we? I mean, is there enough even knowledge in the general, IT pool to really be a meaningful contribution to? I think Cloud.com and with its OpenStack ties, right, has a large kind of IT community of developers from large vendors. But from the Eucalyptus point of view, I mean, do you get, how's it, like the community? Is it a big
It's excellent. No, there's a lot of community contribution that's out there, and it comes in a variety of forms. I mean, there's certainly code contribution that people make. They make contributions to the core. They make contributions to things that integrate, the platform to something else. I mean, data centers are all about integrated software, and people are constantly contributing integration things. But the real contribution we haven't seen yet, and that's going to be in the ecosystem. Right? That's really what Amazon is teaching us, is that, yeah, you're going to get a lot of people who are going to want to help build the cloud platform, and then you're going to get a lot more people who are going to want to help build what runs on top of the cloud platform. And that's true for Linux, right? We saw that with Linux as well. A lot of people were contributing to the Linux kernel early on. If you look at a distro and compare the lines of code in the kernel to the lines of code in the distro itself, it's a no-brainer, right? So it's the ecosystem where we're really going to see the contribution uptake.
I think it might be a little bit aggressive to say that aggressive prediction, not aggressive person, to say that open source is going to just flat out dominate the data center, and that I think there's different types of constituents, right? There's the people that love what you just said. Hey, I got a problem, 100,000 other people have the problem, I'm going to get the resolution as quick as possible. There's other people that value more conservative nature. I want simplicity, I want integration, I want end-to-end end-to-end tightness of all the features and solutions. I want one throat to choke when I call support. And these different personalities in the data center world are going to be out there for a long time. And so there will be the open source dominated space, and there'll be the closed source dominated space, and then there'll be kind of that middle that could go either way. What proportions there'll be, again, I'm not going to predict, but I think there's definitely room for both approaches. Big market.
Yep.
Is it fair to make a comparison between, at a consumer level, between Apple and a PC in terms of Apple, there's one thing is a very tight integrated experience, and the other is you can swap and mix and match and roll your own to some degree. I mean, it's a trade-off of flexibility over and known problems over something that you just assume the vendor or the provider knows what they're doing.
But if you look at particularly the iPhone and the iPad, the things that make it interesting is the ability for third parties to extend it. So to Jay's point on the ecosystem and to Rich's point as well, it's about the collective user base having broad adoption where they can take the domain knowledge and extend your core platform. And that's really interesting because as a software maker, I understand how to make a cloud orchestration platform. As a domain user, all you people out there, you guys solve real problems. And when you share that domain knowledge, and we give you the capability to extend the platform, whether it's Amazon, whether it's Nimbula, whether it's Eucalyptus, it doesn't matter. If you can extend the platform and you can do useful things with our tools, that's the key. And that's really what makes cloud interesting, is because our DNA is open APIs, hopefully open data, extensible architectures. That's why all you guys are Puppet users, right? It's because you can sit there and you can do really, really awesome things by creating Puppet manifests to do things. And in the cloud, we got to do the same thing.
So just to add to this, I think it's very important where you draw the line. Whether you're drawing a line down to the concrete where the data centers are, whether you're going up the value chain and kind of going up and totally making a complete open source hardware stack, having your own built hardware, as well as, or you're going with a hardware manufacturer with a complete design, or you're going up and having variety of different open source stacks, operating systems, and so forth. So where you draw the line, to draw your analogy, at some point you would want to give off, give the responsibility to someone who can do that job most better way, and then you build on the top, leverage the ecosystem power to kind of gain more adoption and other things, I guess.
All right. So I mean, so building on this idea of an ecosystem, right? This idea of extending your platform. Amazon has been, I think, incredibly successful at building an ecosystem, and then some would claim, and then cannibalizing it to some degree by building in all the new features that Amazon Web Services is continually building out. I'd like to hear a little bit about Amazon's ecosystem strategy, and then from everyone else. So Eucalyptus, Nimbula, and Citrix, but Cloud.com is a little newer. CloudStack
is the
and those are a little newer. Like, what are your strategies in trying to, I guess, mimic Amazon's growth internally?
Yeah, I'll just add, to answer the ecosystem strategy. It's very simple. We are providing the infrastructure as well as the platform services so that you can innovate on the top. You can innovate as much as quickly. There are tons and tons of new innovation that's happening on the top of the cloud. I'll give you a simple example. This is one of the newest stories that happened that came out just a few days ago about how many people know about Vimeo? Vimeo is a video transcoding company. Okay. And just kind of talking about the ecosystem that is building in a very innovative way. Vimeo has, and this is also tying to business models questions, right? Vimeo had a really cool, they have several different algorithms to people go in and actually upload their videos, and it gets appeared. It's a great video distribution company. So they have two models: freemium model. The free model as well as the premium model. The free model is optimized for cost, and it is okay to actually, if anybody is uploading video, they wait a little bit, and it's okay, but they are optimizing to use the spot instances as well as reserved instances, and and so forth. While the premium model, where they're actually people are ready to pay for the resources, people have paid for the premium account, they have a direct relation with reserved instances. So free offering is actually optimized for cost. They use spot instances for their business model innovation and optimizing their cost. And for premium, they're actually using reserved instances and so forth. So you see these business model innovation will never happen or even if ecosystem is not kicking in. They have built specialized algorithm that will say, if go and check for spot instances, and if it's not available, go and fail over to on-demand instances. So they are building a complete framework around that so that others can also take advantage of it. So these are some of the ecosystem, looking at like 2 years now, how these different types of newer ways of building architectures are actually coming along.
Right. You guys, can you guys chime in terms of how you're trying to build an ecosystem similar to what Amazon has done, but on the private cloud side?
Yeah, I think we're probably the ones that are farthest on one end of the spectrum. So we support the AWS API. We've actually done 4 APIs for Eucalyptus, just to make sure that the platform will support other APIs, but sort of people vote with their apps. If you're trying to get a technology off the ground, really what you want to do is leverage the application ecosystem. And in cloud space today, and this is just a statement, it's not a value judgment, there's one answer as to where the apps are today, and that's AWS. Right? There's just a vast array of free software that's available in AWS. People are developing for it. Maybe it's because of the economics of it or the ease of use or whatever, but it's worked. And not only does it work in terms of free software, it works at scale. Right. So you've got now a combination of things that makes that community the driving community for cloud. There are lots of applications, and it works at scale. And when we commercialized, one of the things I had to promise our VCs, it's really, really hard to get VCs to invest in university projects. And one of the things I had to promise was that we would be very customer focused. So the difference between the research project and the commercial entity for us was we just started focusing on the customers. And from that moment forward, it was the AWS API. When that changes, we'll do whatever the customers ask.
Yep.
So I think I'd like to add, excuse me, it's not just what you build on top of the clouds. And when you do talk about building on top of the clouds, having common APIs is absolutely a key thing. But the question, when you're selling cloud infrastructure software is how can you get other people to slide their services, excuse me, how do you get the people to slide their services into your cloud stack so that it feels like a native service, so that we as Nimbula don't have to go and provide every single data service and every single network service and every single security service. And that takes a lot of infrastructure work. And this is pretty embryonic, so I'm not making a statement about current product, but some goals that we have. When somebody delivers a service in your platform, it should be managed as well as your existing services in the control plane. They shouldn't have to do extra work to keep the services up and running. Whatever your permission scheme is, and we think we have a pretty interesting permission scheme, it should apply to objects not just that you create, but the objects that your service partners create. And lastly, when you go to launch something, when end user goes to launch something, that they don't just have in their launch plans the ability to say how they want to interact with your services, but how they have the ability to interact with your partner services. And so that in the end of the day, the end user cannot tell at all the difference between a third-party provided service and something that came native with the cloud software. And I think that's where it has to go to build not just an ecosystem with a large number of people, but a large number of successful people. I think is kind of the thing I'll try to add to it. Not to take away from what many of the other guys said, because that stuff's critical as well.
Just to add one more point to this, the key towards adoption and the ecosystem, and that has worked for Amazon, is having simple APIs. Like I'll give you a simple example on one side of the fence where S3 is just 3 or 4 APIs, get, put, update, delete. Now, and it's a simple distributed redundant data store. There is no hierarchy. You can mimic a hierarchical structure on top of S3, but the basic idea is it's a flat data store, and you're adding more features. There are several new features like versioning, having requester pays API and ACLs and all those things, but the API itself is just 4 functions: get, put, update, delete. On the other side of the fence, the ecosystem has to be driven not only by open source, but also from commercial vendors, right? So like I was at the Citrix conference, the other part of Citrix, right? Where I was able to demo a really cool thing, a complete Zen app virtualized desktop solution running under a Amazon VPC, virtual private cloud environment, using CloudFormation in like 2 minutes. You can set up that entire environment within 2 minutes. So ease of use and for commercial software as well as simplicity both really drive the key adoption here.
All right. Mark, I'd really like to hear from you on this, just because with CloudStack, you're involved with OpenStack, right? And that's kind of the the emerging open source community, if you will.
And really, since I'm the open source guy, I have more of a myopic view of not the customer ecosystem, but the user ecosystem, and specifically the open source user ecosystem. So I see, and OpenStack is a fascinating creature to me, because usually you start out with someone developing a piece of software to a specific problem, and then after a long time, you start getting contributors. Like, I remember when Luke started Puppet, it was just Luke, and now there's all you guys and 60 people here in Portland. But OpenStack has this huge ecosystem of developers before it got users. It started, obviously, with NASA's that big user. Now you got this big, huge group of users, of developers trying to come together to bring a platform there. But I think the ecosystem that's interesting, and the one that I focus on, is taking all those components from your legacy data center, so storage, but the new distributed storage players, and working with the automation management tools like Puppet and Rundeck, and the open source monitoring tools that have good integration points so you can develop tool chains. That's really sexy and exciting, because as you guys all know from being sysadmins and developers, that systems management is broke. It's awful in the legacy world. And I have this great hope that in the cloud world, with a level of abstraction and this sort of new philosophy of automation and open APIs and all the things that evolved because of all the headaches we've had for the last 20, 30 years, that this ecosystem to me is very interesting, because we sort of have a set of norms that provides that foundation for everybody knows these are how you got to play going forward. You have to do automation. You have to be able to configure infrastructure that scales. You got to do lots and lots of things that sort of we built infrastructure in the past and then tried to manage it after it was up and running. Hopefully that evolution of infrastructure as a service and platform as a service that we're seeing today will have this next generation of tools like Puppet, which actually after Luke's keynote yesterday, I was very jazzed to hear where they're going. But that new ecosystem is people that are looking at how to operate at massive scale, how to operate with automation, how to do high availability. And because of the economies that have evolved, all of us have access to the highest level of IT competency at a price that's unheard of. It's so low compared to, mid-90s when you'd buy a 500 gigabyte filer and it was $500,000. Now you can buy 500 gigabytes and make it highly redundant and a lot less. It's just interesting. It's just interesting. And that ecosystem is the one that's evolving. And then to Jay's point of solutions and one throat to choke, we focus on that on the business side. But right now, I think the open source platform sides, particularly with CloudStack and OpenStack, is very, very interesting.
Right. I mean, speaking of I think that's a kind of an interesting divergence, actually. I mean, we can talk about the one throat to choke on the business side versus this ecosystem on the other side, right? So, I mean, how critical is, I mean, let's say you need a hardware partner to go to market with. You need a Puppet. You need this ecosystem to do the automation, to do kind of some of the systems management configuration stuff. On the other hand, customers might say, like, we want to answer, we want Nimbula to answer for this. We want Eucalyptus. We don't want to have to talk to Puppet about this issue and Nimbula about that issue. I mean, how do you kind of manage that seeming divergence in strategies?
Yeah, that's a really big challenge. I think that's a really important point. So, and I think this is where we see the technology, the maturity of the technology lifecycle. So we encounter this all the time. We come in and we have this ecosystem of software, open source software that the others do as well. CloudStack, a lot of the stuff is compatible. And people say, okay, if I have this kind of a problem, who do I call? And there's two ways that that's getting solved today. One is through systems integrators. We're seeing a huge business for SIs who say, look, I'm an expert in this technology and that technology and this technology. I'm your tier 1 support mechanism, and I have back-end contracts with these various providers. That works great. That actually, they're specialized in customer service, and they've got, quick reaction forces and so on and so forth. So there's kind of, I don't want to say a cottage industry, but there's been an industry that, has grown up around this. And then the second thing is, and this is something I think is really unique to open source, is partnerships. We go to market with partners all the time. And it's really not that hard to work out, who feels the fold call first, and how do we, cross-train the support people, and so on and so forth. I mean, ecosystem is more than just software. It really is the relationships between the entities that are building and maintaining this software. And it comes in all shapes and sizes. I mean, Puppet's a good example, right? We have customers who use Puppet and Eucalyptus together, and we have different ways of managing their expectations and the business that comes from that, whether they're users, open source users, or actual paying customers. But the point is, the ecosystem for us is both the software that we've made work together and the relationship we have with the company.
Yeah, I think the relationship aspect is huge, like Rich said. And I think in partnerships, I think you really want to search for quality over quantity. The reason I was talking about, what are the principles around your extensibility framework, that's not just a technical matter, and a usability matter, but it's a matter of how native do your partners feel in your platform? Do they feel like a bolt-on, or do they feel like a piece of it? And if they feel like a piece of it, you wind up with better compatibility testing, you wind up with real certification programs, you wind up with all the joint support training, you wind up with the relationships that matter. Now, obviously, that takes some effort on the back end, and what the engineers like to call overhead in the company. But that's why you have to focus on a few people that are adding a tremendous amount of value and cater to that. Especially as a small company. As a bigger company, it can be more promiscuous. But as a small company, you really got to target what you want and what your users want you to target. And so that's the strategy. And obviously Puppet being one of the ones that we're very excited to work with. So that's kind of how we treat it. All right.
I do want to get into. I mean, one more question on open source before getting into, I guess, some operational stuff. But one thing we were talking about earlier was this idea of clouds as like a new channel for software, for open source software, like a channel to consume it, right? Because you might not be downloading the latest Linux distribution. You might be downloading an image from a cloud provider that happens to be running that distribution. Like, I mean, did you see that as kind of? I'm wondering how you guys see the cloud, the various clouds, right? I mean, there are 4 of them on the panel right now that could. That could serve as a consumption model for any number of different services.
Yep. I'd like to add to kind of embellish a little bit on that same thought. What we're seeing is, and not just from open source side, but enterprises, enterprises is not layers of stack anymore. The vision of the cloud-ready enterprise is not that there are layers of stack, but they are a collection of services. So this whole idea around not having to manage servers has now moved to managing services is a very important element towards this whole movement. And I think cloud being used as a delivery platform for these different software vendors that are out there is one of the key value propositions. And you can see things like Ubuntu 10.10, they have released in a really cool way. In fact, there are trials that they ran for 10 minutes called 10.10.10. It was really cool too, how they can actually bootstrap that whole process, and then you can run the trials within 10 minutes in the cloud and get a feel of the product, as well as then go back and test it. So this whole, we are not only seeing within these newer tool sets and newer products, but also old existing enterprises are also delivering their existing software based on the services that, in a way of services, changing their licensing models, changing their philosophies around that, and cloud as a delivery platform is growing very, very rapidly.
But this is something we saw early on. I mean, this absolutely is happening. So I'll speak for the people who are not here, the RightScale people. We've worked with the RightScale people for a long time. They provide open source Ruby gem, and it's not part of a Linux distro. That's shocking, don't you think? Most of what runs in Amazon is Linux. These people are a Linux Amazon business, and they're not using the Linux distros. And they are distributing software. So when we saw that, and a lot of our users use Eucalyptus and software that they get from Amazon, just out of the box. What we discovered was that Amazon and other clouds as well, I don't want to just pick on them, but and now us too, are becoming a software distribution channel. And it's not really replacing the distro. In some cases it is, right? The distros still do QA, they still do package dependency management or whatever, but if you think about it, the image and templating and all these things for managing services really give you a way to deliver software in a variety of models. You can deliver it as a service, you can deliver it on-premise. If it's running on Eucalyptus, you can deliver it on-premise as a service. That flexibility is sort of the next generation of what we're going to see in software distribution, and I think the clouds play a very, very important role in that.
All right.
So I think ISVs, the traditional software vendors, are in for a massive change if they're not there already. There's really two ways that they come about their business in the future. One is to deliver things as software as a service. Amazon's been a great way for small companies to get a SaaS running, and then sometimes people decide, okay, I'm now big enough, I need to go build a private data center and run my SaaS there, but they're delivered as a service, whether it's public or private, end user doesn't know. For people that want to sell shrink-wrap package software to companies, and as these companies develop private clouds and clouds that are automated the way that an Amazon or a SaaS company are automated, the whole licensing structure that these software companies go through is going to be disrupted. I think one of the reasons that Rich keeps talking about how open source and cloud fit together is because open source, they don't have the licensing problems. Closed source doesn't have to have licensing problems. Like Oracle and Microsoft don't have to do the things to you that they do to you. And I think as public and private and hybrid clouds take on a more prominent role in IT, people that still sell shrink-wrap software are going to have to license it in a way that's tied to customer value, not tied to some arbitrary metric like number of computers it touched over the last year or something like that.
All right. So I want to kind of make a left turn and go into some lower level stuff. Not so business oriented, but I mean you brought up automation, right? And I mean so I'm curious, right, with the advent of Puppet and some similar products with the advent of cloud computing and all the talk about automating these processes. Like where are we now though? I mean, realistically, how automated can a data center be? Like, Amazon, I mean, and maybe Jinesh can talk too about, I mean, we hear a lot about Amazon, how automated Amazon's cloud is, right? But I'm curious as to how automated you guys think it is actually realistic at this point. And like, what's a sysadmin's job?
So at the scale at which Amazon is operating, we cannot afford if we don't do the automation that we are doing today. It's all server to human ratio, how you actually bootstrap some processes, how do you isolate failures, how do you design networks and design data centers in a most effective way so that you keep your costs down as the primary metric, but when designing large data centers. All of these are extremely important, and Amazon takes enormous pride in building these data centers at scale. And that's why this thing, efficiently building efficient processes, not from the ground up, that can scale at the level as like other services as you're seeing are growing. For example, just S3, the recent number that we released was 290,000 transactions per second. That's hitting S3 today, and it's to operate at that scale. There are no commercial tools available, so we have to grow those tools organically within Amazon itself. So these are the things which are extremely important to build large data centers at scale. Okay.
No, I have to change it. I'll get enough.
Okay. Well, I mean, so from Jinesh has been silenced, I guess. From the private cloud guys, I mean, is it possible at this point to do within a smaller individual corporate data center, let's say, what Amazon's
I think this
doing?
automation thing actually needs a little bit of thought. So most system administrators today use automation. They script everything. And that's because it scales and because it's repeatable. Those are two really important properties if you're doing system administration. What the cloud does is add a third benefit to automation. That is, it separates the infrastructure management from the application environment. And that's the thing that we're not seeing yet. Right? If you look at most data centers today, and I was just having a conversation before lunch with someone who was thinking about putting a cloud in their data center, the application knows about, either implicitly or explicitly, an awful lot about what's going on in the infrastructure and specifically in the configuration. Not necessarily the hardware, but how it's configured. And so system administrators today are kind of living this dual life. On the one hand, they're managing infrastructure, policies, pieces of hardware that are general purpose. On the other hand, there's this configuration linkage, which isn't always made explicit or documented or source code controlled, that they have to make sure is right. And the policies and the procedures for making sure of that rightness are not automated. What the cloud does is add that third component of automation to data center management so that you can provide scale. So that now the application technology lifecycle and the infrastructure technology lifecycle are divorced. And if you want to move the infrastructure forward and keep the application stationary, right, because you've put a lot of investment in your development, you can buy new hardware with the private cloud and swap it in. And because the abstractions that the applications see are consistent, it will continue to work. That's really the driver in the enterprise from an operational perspective for private clouds.
So one more thing to add. And the reason Puppet and others are so popular is one benefit that cloud provides is the agility part, right? And prior to the cloud, before even in any other, in the pre-cloud era, so to speak, it used to take more than 3 or 4 weeks to get your machines up. So if it was okay to spend 6 hours of installation time and configuration time of software on top of that hardware that just was procured. Now the instances are coming within minutes. You can rip and replace a server within minutes. So you cannot afford to have that 6 hours of time frame to install, configure, manage all the software on the top of it. So this agility part is extremely important that comes in and makes this thing even much more lucrative to use.
All right. You're going to add something?
I'm going to try to add a little bit. So, I mean, your question was, how much is here today? I mean, obviously, the automation is critical, and I can't agree more about the separation of the app and the infrastructure. I think the problem today is most applications are still written such that they depend on the infrastructure. A while ago when Amazon had the outage, which, by the way, the press tremendously overblew, in my opinion. I think it was terribly unfair. But Amazon put out some amazing best practices on, well, this is how your application would survive this sort of thing. And Netflix put a big web page up and said, hey, this is why we didn't go down and why we're so smart. And if you take advantage of what cloud brings and you take advantage of new application development practices, you actually can move the operations staff exactly in the direction you're talking about. And the direction is overall capacity management, proactively looking for hotspots rather than trying to figure out different apps individually, because the app owner takes care of that more, and looking out for how your customers feel in aggregate, right? Are all my customers using instances that are too? Do I have a customer whose instances are all too small? Wow, they're probably unhappy. Let me call them before they call me, right? You want to move people to aggregate level management. You want to move them to proactive engagement with the customer and not worry about the apps. But for that to happen, the app has to change to meet the cloud halfway. And so I think that's what's stopping maybe the utopia that you're referring to.
All right. Well, as a member of the press, I like to think I didn't overblow that story. But and I think that's a very good point, though. And I think that actually the press, in some regards, highlighted that very nicely during the outage, which was this idea that application development has to change now to meet what the cloud can do. Because if you stick with this is kind of the same traditional way of doing it. A, you're just asking for trouble, especially if you're running in a cloud that you have no control over. And B, you're not taking advantage of all that it has to offer in terms of automation, in terms of region failover, right? So maybe Jinesh, you can talk about, in talking about a global scale, cloud platform like Amazon, how do you write applications to take advantage of that?
Yeah, that's something which we do as a part of my evangelism effort as well. We have to, it's very important to design applications that truly take advantage of the cloud infrastructure. You will be able to move to the cloud. Your flexibility of the cloud provides you to move applications and run it and get rid of the hardware, get rid of the heavy lifting that is involved in managing and maintaining a data center. So you will be able to take advantage of all the cloud, some of the cloud benefits. But if you want to really implement elasticity, and this is something which I'll discuss in part of my talk, you want to implement elasticity such that they scale and they shrink and expand your infrastructure or your architecture based on your needs. Build web applications that sleep at night. That type of applications when there are no, when you actually save, you turn off your infrastructure, you stop paying for it, and you actually make a significant contribution to your business, to your business metrics. You have to build architectures to adhere that. And there are several white papers, several technical guidance, webinars, others available on our website. There are basic, simple things like loose couplings, the things that we have been talking about in service-oriented architectures since several years. Those are even more applicable in the cloud today. Building more loose coupling, having queues in between, building redundant architectures across multi-AZs. Instead of running 100% on one availability zone, split your infrastructure in one-third of your infrastructure, run it in 3 availability zones, so you have redundancy in your application architecture. Now, all these are extremely important, good best practices that help us, will help build better cloud architectures.
And I would add that I think that we stop thinking of applications, which are monolithic programs that do things, and start thinking in the terms of services. So, and the service not only implies that it has an application that allows you to do CRM or billing or whatever your task is, but it also has these other elements of availability and quality of service. And I think in this group, that's why things like DevOps are popular, because you've got to think about all these operational components as well as what the application that's being developed and how that's delivered. So service delivery is where we're going in all aspects, whether it's at the infrastructure level, whether it's at the platform level, whether it's at the application level. And the operations world and the development world have collided, and that kind of thinking of not only what it does, but how well it's delivered has to go into your thinking as you go into the cloud.
But I think there's also something to be learned from the Amazon outage. I think that there was a lot of consternation over it, and some of it was around this notion that, Amazon was not providing the application reliability that people had expected, foolishly in my view. But there was a second piece of this, and that is going back to this notion of transparency. This is a function of SaaS, one of the things that I saw a lot of complaining about in the blogging that was going on was not that there wasn't an outage, but that no one could tell why did the outage occur, how long was the outage going to persist, what specifically did they have to plan for, other than the fact that it could be, within an AZ or it wasn't within an AZ. I mean, a lot of the criticisms, which Amazon has responded to, I think, I think they just got caught out by this, but it's something that I think we're going to have to deal with in a services world. Is now when things happen and you're behind a service API or behind a service venue, you really have to think about how you're going to communicate that kind of information so people can make plans, specific plans that are tailored to their particular business. If I know it's going to be 2 hours, maybe I do nothing. Maybe I start working on, DR, so on and so forth. But if I don't know, and with these SaaS